Alright, so this is a Minecraft implementation of the hardware version of the Hamming code. We initially thought we wanted to do it on a breadboard, but we figured this would be more innovative. So let's get to explaining the different segments of this setup. Alright, so first, here we have the inputs, and for an 8-bit setup, we have 4 different data inputs available as shown by the green boxes. Right? So these data will then be shown up by lights, indicating the data bits in green and the parity bits in red. And for an 8-bit setup, there are of course 3 parity bits because there are only 3 distinct powers of 2 that are lesser than 8. So instead of breaking each circuit in order to introduce error, we've included a setup of different XOR lines, different XOR gates in order to inject single bit errors toggled by these switches as shown. And correspondingly, the affected parity bits will be shown up in lights after we introduce single bit errors, as shown in this handy little section here. Yeah. Alright, so after all the error correction will be done here, and the final output will be hopefully to show the original message to the receiver, and ideally the receiver should receive the exact same message. Alright, so let's begin by testing. This is taking a while, but alright, so say we want to introduce a message 1, 2, 4. Now 1, 2, 4 are the data bits, but in the 8-bit arrangement they correspond to bits 3, 6 and 7. Now this is because the parity bits here govern only certain types of data bits. For example, the first parity bit will govern data bits whose binary representation has a 1 in its least significant data bit, and parity bit 2 will govern data bits that have a whose binary representation has a 1 in its second least significant bit. So that means parity bit 1 will govern bits 3, 5, 7, parity bit 2 will govern bits 3, 6, 7, and parity bit 3 will govern the bits 5, 6, and 7. And as mentioned by my peers earlier, that is why parity bit 2 has lit up in order to restore parity with bit 7. So now we can see that the receiver has received the same message here, right? So let's introduce an error to say this bit. So we've introduced an error to bit 1, and as such, the parity bits affected are parity bits 1 and 2, right? Because parity bit 2 has to govern bits 3, 6, and 7, and because 7 has been set to 0, it has lit up in reaction. Through this line of XOR gates, we have restored the original data, and the receiver should still be able to receive the correct message, and that is data bit 1, 3, and 4, or in other words 3, 6, 7,